long lesson. I'll invite you to go to y equals. Okay, turn it on, I guess. On y equals where we were, and you've got sine of x. Okay, that's what I've done already. Put that in there, sine of x. And I would encourage you to make your window sort of like mine now. Now we're going to have to change the y a bit. So I would go x min -1, x max 6.5. Let's get to one full cycle in there. But the y min now, let's go to -4, let's say, and +4. Okay, so if you could make your window look sort of like that on your calculator or your device, whatever you're using right now. If you have graphing capabilities on your phone or computer. So if you put the window like this and you hit graph, all right, this is what your sine graph looks like now. Just a little more flat, but that's 1 right there. So that's our max there, and -1 is our minimum over here. Okay? Okay so far? All right, so what happens when we vary a? Well, obviously 1, if a is 1, we have a normal graph. It's called, a normal graph, and its amplitude equals 1. And I want you to graph these as well down here, these two. And you can graph all 3 of these together so that you can kind of see how they compare. All right, so just like I'm doing here, I'm going to do 2 sine theta. And I'm going to do 0.75 sine theta. And so there's your original one. Here's the 2 sine theta. And there's the 0.75 sine theta. All right, so you can pretty easily see that this A value over here indicates sort of what the amplitude is, right? 1 has a maximum displacement here from the center line up 1. 2 goes up to 2. 0.75, hard to tell, but it just goes up to 0.75. If you hit the trace button, you can move your cursor along each of the graphs, and it'll show you in the top left corner there which graph you're actually on. Again, a bit tricky to see maybe, but you're on, here I'm on y equals sine x. And if I hit the up arrow, I go to basically the next function that I've put into the calculator, which is 0.75. Okay, and then up again, I'm at 2 sine x. And so you can kind of, you can see which graph is which that way. All right. Okay, actually, just take a moment here. Why don't you take a moment to just erase these and do the cos. Okay, do the cos. So do a couple cos. Just do cos, maybe x, and do cos of maybe 2x. Whoops, sorry, 2 cos x. And see how they compare. So obviously, this looks very much the same, and you can kind of see how the cosine graph starts at 1, right, for this one, and then goes down through 0 to -1, back up to 0. And then the y equals 2 cos x just has a double the amplitude. Okay? Good with that? So the A is the amplitude. All right? That's pretty easy. That's what that does. The other thing they want to talk to you about, I guess, is the B value. So y equals cos of B x, and y equals sine of B x. So this B value, obviously, if you recall from our transformations chapters there, that's going to do something, another parameter. So let's see what that does. And if you want, you can do whatever you want here. You can put in a 2 there, 2x if you'd like. Or maybe just do one at a time so you can kind of see what's going on. Or compare it to the regular cos. But cosine of 2x. Alright. And we'll compare that with cos of just x. So that's what these two look like. Now we'll notice that the amplitude is the same. See, the amplitude is the same. It's 1, which would make sense because if we have y equals 1 cos x and y equals 1 cos 2x, we see that the a value is the same. So that's good to know. If b is 1, we have sort of our normal cos x graph. If b is 2, we notice something interesting that happens. So this is with b2. Okay? And what you see, you look at it two different ways, I guess, that this is one regular period, okay, for the cos graph. It's 0 to 2 pi. That makes sense. But here, the period for this one is actually half of what a normal period would be. It's only 1 pi. Or think of it this way, that there are 2 complete cycles where there normally was 1. So what does the b value do? Well, you can think of it 2 ways. You can think of it as 2 cycles in 2 pi. Okay, 2 instead of 1 cycle, right? That's 1 cycle in 2 pi. This one is 2 cycles in 2 pi. So if you got to make 2 cycles over the same length, your period length decreases. So the other way you can think about it, this 2, the period, or I think we are going to call it period length, maybe a lot of times as well. So the period length is now, because there's 2 cycles in 2 pi, the length for 1 cycle is 2 pi divided by 2, or just pi. So that means that 1 cycle covers a span of 1 pi, not 2 pi. And as a matter of fact, we can make a general sort of formula for period length. That's for sine and cos theta. Is this: period length equals 2 pi over b. And that always works. 2 pi over 2 in this case gives us a period length of 1 pi. So you don't want to write this down here. Okay. Now, I fear that we have a little bit of information overload, so I'm going to stop here. I don't think there's too much more that they would really want me to accomplish, to tell you the truth. Just looking at the key ideas now on page 232. If you look there, it talks about maximum, minimum, talks about amplitude, talks about periods. Okay, still domain and range, which we didn't explicitly cover in this lesson, but we talked about that earlier, and you can see that's pretty easy. Talks about amplitude, what A does, and it talks about period length and what B does. So I think I've covered everything in this section that needs to be covered. We only have about 9 minutes of class remaining, so I will give you some questions to do here, and then I'll give you a little bit more time tomorrow to finish this sort of long section, okay, as introduction. So.